Alright, today you're going to talk about properties of definite integrals. And so the first one is if f is defined at x equals a, then the antiderivative from a to a is equal to 0. So remember we talked about a width of 0 where we're starting at 2, we end at 2, what's the area equals 0. Anytime you have where your starting point and your ending point are the same, then your area is always going to be equal to 0. The other one, if f is integrable, I can't say it, from a to b, then if I change my bounds, we kind of talked about this a little bit, but if I change my bound, if I instead go from here, I'm going from b to a, essentially I'm going backwards, then it's going to be the negative version from a to b. And so if I'm subtracting my smaller from my bigger, then I'm going to have a negative area. We're essentially going backwards, if you want to think about this. It's kind of like the idea of going to the left. The last one, if f is integrable from a to b, and I have some sort of midpoint, then the antiderivative is if I just sum my two areas. So if my integral creates two different areas, such under as an absolute value, and that value, x value is c, then I'm just going to have to split up in two different integrals and sum the two areas. Number 1, find all the values of k for which negative 3 to k of x squared dx is equal to 0. And again, I told you on our first property is when our width is equal to 0. So that means in order for our width to equal 0, that means k has got to equal my starting spot, which is negative 3. Alright, number 2 is the antiderivative from 0 to 5 of negative x over 3 plus 4. If you want to think about it, what I could do is I could split this guy up and do 0 to 5 of negative x over 3 dx and add that to the antiderivative from 0 to 5 of 4 dx. And so since this guy is negative, one of our properties is I could switch my bounds. I could go from 5 to 0 and do the opposite version, which gives me a positive form of x over 3. And then I have my other integral. Oops. Wrong number. Sorry, guys. So this gives me the antiderivative of x squared over 6 going from 5 to 0 plus 4x evaluated from 0 to 5. And so this will give me negative 25 over 6 plus 20, which is, let me see here, 180 minus 25 over 6, 155 over 6. And we're done. Number 3, the antiderivative from 0 to 1 of 5 minus 3x times the square root of 1 minus x squared. Because I have something so complicated and this is going to require u substitution, I'm going to go ahead and split it up. Equals the antiderivative from 1 to 0 of 5 dx. And instead of dealing with a negative, I can just do positive, and I'm going to flip my bounds. So I'm going to go from 1 to 0 of 3x times 1 minus x squared to the 1/2 dx. Again, I can make that positive because my bounds were switched. And so now we can do u substitution. U is equal to 1 minus x squared. Du is negative 2x dx. Dx is equal to du divided by negative 2x. And once again, since I'm switching my bounds, I have to have a new a and new b. Oops. So the u coordinate at a is going to be, so my a now is 1 because I flipped my bounds. Again, my a now is 1 since I flipped my bounds. So I'm going to plug in 1 into u. And so 1 minus 1 squared is equal to 0. And then now I'm going to plug in 0, that's my new b. Uh-oh. Sorry about that, guys. I'm not sure what happened. It got all erased, so I went back and fixed it. So anyways, I was talking about plugging in 0 into my b. So 1 minus 0 squared is equal to 1. So now we can plug in our new bounds. I'm going to go ahead and take the antiderivative of 5. That gives me 5x evaluated from 0 to 1. And then now I'm going to just go ahead and plug in. And so instead of my a is now going to be 0. My b is now going to be 1. So it's kind of funny that it flip-flopped again. I have 3x times u to the 1/2 times du over negative 2x. Again, my x's are going to cancel. And so that gives me, if I take the antiderivative, I plug in for this guy, if I plug in 1, I'm going to get 5. I plug in 0, I get 0. So 5 minus 0 is 5. So I have 5 plus the integral from 0 to 1. I'm going to go ahead and move my coefficient in front, so this becomes negative 3 over 2 u to the 1/2 du, which is 5 plus negative 3 over 2 times 2 over 3 u to the 3/2 evaluated from 0 to 1. And hopefully you notice your fractions are going to cancel each other out. So I'm left with negative. So 5 minus u to the 1 gives me 1 minus u to the 0, which gives me 0. Or sorry, not u to the 1. When I plug in 1, u to the 3/2 gives me 1. 0 to 3/2 gives me 0. Sorry about that. And so I get 5 minus 1 minus 0, which is 4. Number 4, if 1 to 10 of f of x dx is equal to 4, so my total area from 1 to 10 is 4, and if from 10 to 3 my area is 7, then from 1 to 3, what is my area? So first of all, I want you to notice that your bounds are backwards. So let's go ahead and fix that. So if my total area from 1 to 10 of f of x is 4, and if I flip my bounds to my other one, I have 3 to 10, that means it's going to be negative. That means it's going to be equal to negative 7. And so I want to find out what is the area from 1 to 3. So if you want to think about it, this is my total area is equal to area 1 plus area 2. So I have 4, I'll keep color coded. 4 is equal to negative 7 plus x. And so what does x have to equal? Hopefully you're getting 11. So the area from 1 to 3 has to equal 11.